Okay, this is homework chapter 2. And in this chapter, we will be solving problems 1, 6, 7, 10, 14, and 22. Number 1 says a car travels in the positive x direction on a straight and level road for the first 4 seconds of its motion. So t equals delta 4 seconds. The average velocity of the car is v, the average sub x equals 6.25 meters per second. How far does the car travel in 4 seconds? Well, we know that v equals delta x over delta t when we're speaking of average or average or constant velocity. So we want to know delta x, so delta x equals v delta t. So this is going to be equal to 6.25 meters per second times 4 seconds. And that is going to be, let me get my calculator on clear, 6.25 times 4, 25 meters. The seconds will cancel and we'll get a unit of meters, and that's indeed the unit we're looking for. Number 6, chapter 2 says, a Honda Civic travels in a straight line along a road. The car's distance x from a stop sign is given as a function of time by the equation x of t equals alpha t squared minus beta t cubed, where alpha equals 1.50 meters per second squared, and beta equals 0.0500 meters per second cubed. Calculate the average velocity of the car for each time interval. A is t equals 0 to t equals 2 seconds. And B is t equals 0 to t equals 4 seconds. And C is t equals 2 to t equals 4. All right, let's go ahead and do that. All right, so I know it's 0, it's 0. So x at t equals 2 seconds is going to be equal to 1.50 meters per second squared times 2 seconds quantity squared minus 0.500 meters per second cubed times 2 seconds quantity cubed. And let's see. That's going to be equal to 2.8 meters per second. So A is 2.80 meters per second. B, we're going to have, just change this to 3. And this to 3. And you're going to get 5.2 meters per second. Okay. For C, we're going to do V x final minus x initial over t final minus t initial, and that was going to be 20.8 meters minus 5.6 meters over 4 seconds minus 2 seconds. And that's going to give me 7.6 meters per second. And that's C, 6C. All right, we're on chapter 2, problem 7. It's a calculus problem. It says a car is stopped at a traffic light. It then travels along a straight road such that its distance from the light is given by x of t equals bt squared minus ct cubed. bt squared minus ct cubed. Where b is 2.4 meters per second squared, so it's going to be equal to 2.40 meters per second squared minus, what is the next one? C is 0.120 meters per second cubed, 0.120 meters per second cubed. This is t squared. This is t cubed. Okay, let's see. Calculate the average velocity of the car for the time interval t equals 0 to t equals 10. T equals 0 to t equals 10. And finally, calculate the instantaneous velocity of the car at t equals 0, t equals 5, and t equals 10. How long after starting from rest is the car again at rest? Okay, so for the average, we know that delta V equals delta X over delta T. V, I'm sorry, not delta V, V average. Delta X over delta T. Okay, so we need to do this interval. So we need t equals 0 is obviously going to be 0, but t equals 10 is going to be 2.4, let's see, 2.40 meters per second squared times 10 seconds quantity squared minus 0.120 meters per second cubed times 10 seconds quantity cubed. And that's going to be equal to 120 meters. So delta X equals 120 meters. All right, so now we need to do, X final. So now we have X final minus X initial over T final minus T initial. So we've got 120 meters minus 0 meters divided by 10 seconds minus 0 seconds. And we're going to get 12.0 meters per second. And that is A. All right. Let me erase, make myself a little space. Okay, now for B. Get a pen out here. There we go. So V instantaneous is going to be equal to dx dt. Okay, so that's going to be equal to 2 times 2.4 meters per second squared times t minus 3 times 0.120 meters per second cubed times t squared. So we're going to get at t equals 0, v equals 0. And at t equals 5, we're going to have, just put in 5 seconds, 2 times 2.4 meters per second squared times 5 seconds minus 3 times 0.120 meters per second cubed times 5 seconds quantity squared. And our value is going to be 15 meters per second. So that's 15 meters per second. And that's v at t equals 5. Okay, and finally, I have to find this for t equals 10. So I'm just going to change these guys to 10 here and here. I've got 10 seconds and 10 seconds. And for my answer, when you do the math, you're going to get 12 meters per second. So v at t equals 10 is going to be 12 meters per second. Now, to solve for 0, I'm going to set this whole thing up to 0. So I'm going to set it up to 0. So let me pause and clear my board space. Okay, so we've got 2bt minus 3ct squared equals 0. Okay, so we're going to take a t out. So I'm going to have 2b equals 3ct. So t is going to be equal to 2b divided by 3c, which is going to be 2 times 2.40 meters per second divided by, I don't know what that, must have forgotten to erase that, 3 times 0.120 meters per second. Oh, this is second squared, second cubed. And if you go ahead and do that, that's going to be equal to 13.3 seconds. 13.3 seconds. And that's when we are once again at rest. Okay, now we're going to do problem 2.10, which reads, a physics professor leaves her house and walks along a sidewalk towards campus. After 5 minutes, it starts to rain and she returns home. Her distance from home as a function of time is shown in figure E210, which is in your homeworks, E210. At which of the labeled points is her velocity is 0? And you've got 5 points there. Okay, her velocity is 0 when her slope is 0, when her she's not moving any, she's not covering any more ground, so it will it'll have a 0 slope. So that will be at 0.4. So A is 0.4 in Roman numerals, by the way. You should probably check this out. And then it says constant and positive. So that's going to be when the slope is constant and positive. So that's going to be 0.1. C. Let's see, constant and negative. That's going to be 0.5. And D asks for increasing in magnitude, and that's going to be something like that. That's going to be 0.2. And then E is finally going to be decreasing in magnitude, and that's going to be 0.3, where it's like that. This is not going to be decreasing in magnitude. That's simply increasing in the negative direction. Okay. All right. That was number 10. Number 14 reads, a race car starts from rest and travels east along a straight and level track. For the first 5 seconds of the car's motion, the eastward component of the car's velocity is given by v sub x of t equals 0.860 meters per second cubed, 0.860 meters per second cubed times t squared. And what is the acceleration of the car when v sub x equals 12 meters per second? So v sub x equals 12 meters per second. All right, the first thing we need to do is we need to find t. So when 12 meters per second equals 0.860 meters per second cubed times t squared. So I'm going just to solve for t here. All right, so we've got 12 meters per second divided by 0.860 meters per second cubed. Under the radical is going to give me t, and t is going to be equal to 3.735 seconds. So t equals 3.735 seconds. Okay, now I need to find the acceleration at that time. So a of x is going to be equal to dv dt, and so that's going to be equal to 2 times 0.860 meters per second cubed times t, which is going to be 3.735 seconds. And that's a is going to be equal to 6.42 meters per second squared. Okay. Okay, finally, we want to do problem 22, 2.22, which reads, tennis serve. In the fastest measured tennis serve, the ball left the racket at 73.14 meters per second. So 73.14 meters per second. A serve tennis ball is typically in contact with the racket for 30 milliseconds. So that's going to be 30 times 10 to the negative 3 seconds. And starts from rest. Assume constant acceleration. What was the ball's acceleration during this serve? How far did the ball travel during this serve? Okay. So we're assuming constant acceleration, so we can do a v final minus v initial over t final minus t initial. A equals delta v over delta t, which is what we're doing. Delta v over delta t equals that. So we've got 73.14 meters per second minus 0 meters per second. And milliseconds, that's going to be 0.030 seconds. And we're going to get 2440 meters per second squared. And now we want to know the distance. We'll use our handy dandy polynomial. X final equals x initial plus v naught t plus 1/2 at squared. We want to solve for this. We know x initial is 0 and v initial is 0. So we're going to have x final equals 1/2 times 2440 meters per second squared times 0.030 seconds quantity squared, and we're going to get, let's see, 1.1 meter. 1.10 meter. And that concludes the homework for chapter 2.